So arrays are declared just like you declare another variable and just like you've declared strings before. Anytime you don't set a variable equal to something, what is in its memory? Right? We have no idea. It's whatever was left over. So if we want to know what was inside, we should initialize all the elements of the array. For example, if I declare this really, really small array, int x of 3, that means the element numbers are 0, 1, and 2, and I print this out without storing anything in them, what will print? Well, it'll be random garbage. We have no idea what will print. It'll probably be addresses and just junk. There are 3 ways we can initialize arrays to 0. The first one is to make it global, and we are not going to do global variables or arrays in this class at all. In fact, we mark down for doing that because it is a security risk. There will be times that making global variables will make more sense, but in this class we're not going to even talk about it. You can declare an array as static. So this means you actually set it equal inside your main function. If you do this, though, it can be reinitialized to 0 every single time you call the function, which is probably not what we want to do. And probably the easiest way to make sure you've zeroed your entire array is to use a for loop. As you can probably imagine, because we know how big arrays are going to be, for loops go really, really well with arrays. So in this example, I have an array of size 3. As long as I go from 0, right, my first element number, to less than 3, which will be 0, 1, 2, as soon as I hit 3, this will be false, I can initialize every single element in there to 0 by just setting the ith element equal to 0 as I go through this for loop. So this is something you should know how to do. Now you might say, well, Professor Casey, I don't want to set all my elements to 0. I want to store something else in them. Well, that's fine too. In fact, we can actually declare arrays where we don't know how big they're going to be. And maybe you type it in as you go, right? You're like, well, I don't actually know. I'm going to type every single element I want, right? Every single variable I want stored in here in these curly brackets. And then I'm going to save it. And my array in this case would be 3 big. But if I had more numbers here, it would be as big as however many numbers I had. So you can actually write arrays like this with an undeclared number as long as you tell it what you want afterwards. So in this case, I've initialized x of 0 to be 3, x of 1 to be 2, and x of 2 to be 1. And it would keep going if I had more numbers. So in this case, we actually do know what it prints. It prints 3, 2, 1. You'll notice these are curly brackets. So if I'm defining and initializing my array at the same time, I can do this. I can set it equal using curly brackets to however many numbers I want. You'll notice there's a semicolon at the end too. Now, actually, this is kind of unusual. So you don't usually see arrays set equal like this. There are certain cases, of course, but most of the time you're going to actually be scanning in numbers into an array or reading them in from a file. So most of the time, you aren't going to set it equal to anything because you're going to be scanning things in. Now, if you do decide to do this, right, say, I want to set the first couple elements to something and the rest, I don't care what they are. I just have some extra. In that case, anything that you don't declare in here will just become 0. So int x of 4, but I've only declared 3 variables here. So I have the 0th element, the first element, and the second element, but I have 4 total. I still need my third element over here. This would actually give you 3, 2, 1, and 0 when you printed out everything in the array. Even if I had 7, right? If this was x7, I would have 3, 2, 1, 0, 0, 0, 0. Now you might say, be a little bit clever and say, well, then if I just set the first element to 0, does that mean every other element is set to 0? And you would be exactly right. This is absolutely the easiest way to know you're setting your entire array to 0. And if you're doing some troubleshooting, you're having trouble scanning something in, I would highly recommend doing this so you know where you're going wrong. I touched on this earlier, but because we usually know how many elements are going to be in the array, or we can figure it out, we use for loops a lot with arrays. especially when we're reading something in either through scanf or through a file, or we're comparing something. So let's look at this. For example, this is called a macro. We're going to get into macros more at the end of the semester, but basically what it is just defining a constant. Anywhere I see the word n size, I'm just going to replace it with 1,000. My compiler does this for me. So if I have a bunch of times I need to use the number 1,000, sometimes it's easier just to replace it with a word. You'll see this a lot when you're doing code for like machines. If I have on and off as 1 and 0, I can use on and off instead of 1 and 0, and it's a lot clearer to the reader. Anyway, we'll talk more about macros later, but anytime you see the word n size here, you can just replace it with 1,000. So here, I've just defined my array extra super big, way bigger than I need it. That way, no matter what, I can scan in and print out a big array. Okay, there's another reason you might want to use a macro, and that's because if I don't know the size of the array and I want to print it out and see how big it is, I can easily go back and just change this number, and it will replace everything that says n size, instead of having to go and find every single instance I typed that number. So it makes your life a little bit easier. Feel free to use macros, especially as we're getting into arrays. Sometimes it'll make your life way easier. So this for loop is 1,000 big, right? We've defined our array as 1,000 big. That means its elements are 0 to 999. So that for loop will count from 0 to 999. And that's exactly what we want. Now, like I said earlier, a lot of the time with arrays, we're actually going to scan the data in. So let's look at a couple different ways to do this. When we scan data in, if we're scanning it into a specific variable, like one element of an array, we're always going to use ampersand, because the ampersand indicates this is just one variable. And even though this is one element of an array, if you remember the table showing where every variable is located, you can see that it is just one variable. It just takes up one memory slot. It's nothing special. These brackets just say, oh, it's just part of a bigger chunk, but all I'm doing is scanning into this one variable. So it actually works exactly the same way as scanning into any other variable. So if I were to scan in to the first three elements of this array, I would just put ampersands in front of each of those individual elements. If we did this in a for loop, which is very, very common, I can simply scan in my element counting with the counter of the for loop. So if I have my for loop using the counter j and it's going from 0 to n size, I can just plug j in as my index number and say, oh, well, the first time I'm going to scan in x of 0, and then I'm going to scan in x of 1, and it'll just keep going through this loop for as big as my array is. And that is by far the easiest way to scan in a large number of data points. Now here's the big one. How do I declare an array when I don't know how big it is? Let's say I'm reading in from a file. I don't know how big or how many numbers or how many lines that file is. So the first method for doing this, and the one I would not recommend doing, is declaring an array size much larger than you need. This is wasteful of memory, but because memory is so cheap now, it's not the most awful thing to do. I would still very much not recommend you do this, but for example, I could declare my nmax, my biggest number for my array, as 10,000, because I don't think that my file is going to be greater than 10,000 numbers. But do I actually know that? No, not really. I could also ask the user. You see these two lines here. I could also ask the user for the number of points. We've done this a couple times before and say, oh, well, just tell me how many numbers you're going to scan in, and hopefully you don't enter a number bigger than 10,000. Okay, so this can work in a pinch, but definitely not the preferred method. Let's look at a couple different methods here. The second method, right, and here we're doing it from a file just to show an example, is I can scan in one number, right? So I've declared my file pointer, I've declared my arrays as 10,000, just guessing that my file won't be bigger than 10,000. Declare my file pointer, open the file in read mode. Oops, I'm forgetting a double quote there. And then every time I scan a number in, I'm going to set it equal to status and see if it actually worked. So we can actually use status with fscanf just like we did with regular scanf. I just have to remember with this do while to increment my n every time I go through, because this is in a do while and not in a for loop. Okay, and actually, because your last status won't work, it'll still increment n before it checks if it didn't work. You have to backtrack and count one less. So again, this is a little bit awkward. It would work for sure. Like we're just checking every single time we scan something in to see if it's not equal to EOF. But it's complicated, it's long, we have to subtract one at the end. Now this EOF here though, that could be useful to us later. EOF actually stands for end of file, and it is a character that's hidden from you, right? Just your computer can see it, that tells your compiler when it's reached the end of a huge data input. So if I have a bunch of data listed in like a CSV file or something, I can say, hey, all this data is entered, and at the very, very last line, it'll read in EOF instead of a number. And that's how I know the file has ended. Okay, right? I've still declared my array size way, way bigger than the maximum data length. And now I actually know how big it is, but this is still kind of awkward. So let's look at a different method. And these are probably the better options. So we can use a while loop, right? We still have to do this weird n-1 at the very end because we count too many. This actually scans in before it checks. So it'll scan in the wrong thing, increment n, and then it'll check for EOF. And once it's done that, it's gone one too far. So we subtract one. Remember, the whole point of doing this is to get the total number of elements that we're scanning in. We want to know how many data points there are. So here, I've shortened this from a do while to just a simple one-line loop that'll scan in until we've reached EOF. What I like to do much better than a while loop is a for loop. And this is because I can do it in one line without having to subtract one, because we're not incrementing until after we check this. So this makes it a little bit simpler at least. So all that's happening here, it's the same that's happened in the last three, is we're saying n equals 0, we're going to scan in from our file pointer one integer, and we're going to store it in y of n, and this n will start at 0, right? It'll increase as we go along. And we're going to keep scanning as long as whatever I just scanned in isn't the EOF, isn't the end of file. So then I can loop and loop and loop and loop and loop, and eventually I'll get to the end of file, and whatever n is at the very end, I know exactly how many numbers are in my array. And I can then use that for the rest of the for loops as I do math or do calculations or do something else with all the data I just read in. So let's look at some common errors to avoid when you're doing arrays. The name of the array, we're going to talk more about this when we talk about arrays and pointers. The name of the array is the same as the address of the first element of the array. I talked a little bit about this. When you go to scan something in, this is by far the most common error with this. When you go to scan in an array, you have to use the ampersand and then the element number in those square brackets. If you don't use those square brackets, you're using a pointer, and you're trying to scan something into a pointer address. Like I said, we'll talk more about this later, but just double check that you're not just using the name of the array. You have to use square brackets. When you're declaring an array, you should always specify the array size. Even if you don't know how big it's going to be, guess something really, really big. Make sure it's bigger than what you say, right? Make sure you have enough room to scan in your whole array. Remember that array elements start at 0, and they go to the maximum size -1. Because they do start at 0, everything's shifted down. So a really common error with that is over-indexing. For example, if I have data 100, this is going to be 0, 1, and my biggest data point is going to be 99. If I were to go data 100, that would actually be the next point in memory after data 99, but it's not part of my array. It's going to be something else. So if I start modifying stuff like that, I can really start to mess up my program. Remember, when you're scanning data in, you can't scan it in all at one time. You have to do it in a for loop, and you have to scan in just one data point. And we do that usually with the ampersand, and then your array name inside the brackets is going to be the counter variable, like I or j. Whenever you're using fscanf, always use the ampersand, and don't forget to close your files. This is kind of reminders from last time, right? Don't forget to use the ampersand when you're using fscanf. Don't forget to use the ampersand when you're scanning in arrays to individual array elements, and don't forget to close your files. All right, well, that wraps up our lecture on arrays today. I'll try and post some more examples and definitely do some in lab where we talk about how arrays work, what the point of using arrays is, and how they can really make your lives easier, because arrays can be kind of scary when you first see them, but they make your life so much easier when you get into big data sets that you'll definitely see later on in your engineering career. So we want to make sure you're comfortable with them. As always, feel free to shoot me an email, shoot me a message if you have any questions at all, and hopefully you'll get some practice this week in your ZY books. Have a great day.